says that a car manufacturer collected data about the preferred car colour from drivers in various age groups. And we can see the data here collected in a two-way table. The first part of the question is to write down the value of B. So you can see here in the table we have B and we don't have the numerical value. So we can work out what B is using one of the totals. We can pick which one. Either we can use these adding up to 58, or we can use these three adding up to 46. I'm going to take the column just because it's a bit smaller. So 46, and then I've got minus 18 minus 7, and that gives me 21, which must be the value of B. Don't forget, we should write down some working to help us if we were to go wrong. So 46 minus the 18 minus 7 equals 21. So that would be our working out. And we've used the fact that that column there adds together to make the total of 46. So it says the car manufacturer performs a chi-squared test for independence, and it's a 1% significance level to determine whether there's evidence that the colour of the car and the age group are dependent or independent. So we have given for us this time the two hypotheses. We know that the chi-squared critical value is 16.81, and we're finding the chi-squared statistic. So to do this, a two-way table like this sort of question, we need to go to the matrix to type in our data. So you can see there we're in second function matrix, and we're going across to edit. Don't forget, we don't include the totals in our sizing. So we have 1, 2, 3, 4 rows. So I need to change this one, 4 columns. So I need to change that to 4. And we have 1, 2, 3 rows. So we can now see that that's my complete data. I do not want to include the column or the row for the total in my matrix. So I'm now just going to type that data in. So 12, 15, 12. And then the next one, we have 7 and our value of B, which was 21. And then, and 18, 4, 10, and 16. And then the last one, which is 17, 12, and 6. Once we have that, we can go to the statistics, and we're going to go across to tests, and we want to complete a chi-squared test. In the observed matrix is matrix A that I just typed it into. We can ignore this part, but it does give us the expected values. So if we needed to find one, we can actually bring it up on that matrix, and then we're going to calculate. And we can see there that we have a chi-squared statistic, which is 18.3. 3 significant figures. And then we need to write down the conclusion of the test in context. So when we're concluding the test, you can either use the chi-squared against the critical value, or you can use the p-value. So it's entirely up to you. This is the test, essentially, and we have a critical value here of 16.81, and that critical value is what decides whether I take the alternate hypothesis or the null hypothesis. And we know that this was at a 1% significance level, so we can see there that we have 1%. Now, the values that we have, if we look at our p-value, I'm just going to write this down as well. So the p-value is equal to, if we're just looking at the calculator here, 0.00, and then to 3 significant figures we have 546, which is roughly equal to 0.546%. So that is less than 1. So when the p-value is small, then we reject the null. So we reject it when it is small. The p-value is less than the significance value, or the significance level, which was 1%, and therefore we reject H0 and accept HA, or for this question I think they actually labelled it as H1, so we should write H1. And we can see that on here because the area is significantly smaller. So if I draw that area on, we can see my area is only 0.5%, which is something like that, and therefore we are firmly in the alternate hypothesis section. You can also use the chi-squared statistic. So if this is a scale from 0 all the way up to infinity, if I have 16.81 here, our value is 18.3. So 18.3 sits over this side, which again points us to the alternate hypothesis.